Just a little disclaimer, this video is in no way meant to be a tutorial on how to acquire and modify a transformer. Stay safe and don't do dumb things that will kill you and then blame it on me. Hello, my name is Michael and I'm going to be telling you about the little melter I made in my backyard for the next 10 minutes or so. The circuit of the melter I made is very simple. Its power source is a wall socket that supplies 120 volts of electricity going at 20 amps. The current is then run through a transformer, which steps down the voltage and brings up the current considerably. This destructively high current electricity then goes through a resistor, which will heat up and melt as some of the electrons are blocked and or slowed down by the resistor, and their kinetic energy is turned into heat and light energy. We can determine the current and voltage output using two simple equations. First is the equation for determining voltage input or output based on the number of turns in the primary and secondary coil. The second equation is power in, which is just the voltage times current equals power out. Using algebra, we come up with the final equation that can be used for determining both voltage and current. If we plug in the values of 120 input volts, 20 input amps, and 100 turns in the primary coil, and 4 turns in the secondary coil, we see that the output voltage is 4.8 volts and the output current is 500 amps. In order to get the most important component for the circuit, the high voltage transformer, I disassembled an old microwave. But I couldn't go straight for the transformer because microwaves also have high voltage capacitors that have a capacity of upwards of 1,000 volts. Many people have died from the deadly shock that these capacitors can deliver because they think the appliance is safe just because it is unplugged. Thus, in order to safely obtain the transformer, I discharged and removed the capacitor with an insulated screwdriver and a pair of electrician gloves. Afterwards, obtaining the transformer was just a matter of unplugging and cutting it away from the other components. I used an angle grinder to cut through the transformer core and gain access to the coils. After cutting through the core, I was able to pry the secondary loose and replace it with an 8-gauge cable that was coiled with 4 turns. I rewired the transformer to the salvaged electrical outlet wire from the microwave by plugging the spade connections of the wire into the terminals of the transformer. I also attached the grounding wire to the core. I attached the electrodes to the ends of the cable by shaving some insulation off of the ends of the cable, then bending the inner wires into a circle that would hold small pieces of copper that were bent into U shapes. Then I used tape to hold them in place in the circles. I tested the output amperage of the apparatus by setting up the multimeter in series with the electrodes and plugging in the wall wire. It was found that the new wire was carrying electricity at 0.076 amps, which is way too low. I tested the output voltage of the apparatus by setting it up with the multimeter in parallel and plugging in the wall wire. It was found that the new wire was carrying electricity at 0.27 volts, which is also way too low. I also attempted to melt steel, more specifically a steel nail, with the apparatus, but the current was not high enough and the apparatus kept on shorting out. The efficiency of the transformer can be found by dividing the output power by the input power. When we do that for the numbers that this apparatus returned, we see that the efficiency was an abysmal 0.000855%. The reason for this terrible efficiency is likely the significant damage inflicted on the transformer core because the core serves as an easy medium for magnetic flux to travel through as it goes from one coil to the other. Thus, removing sections of it like I did would cause a reduction in efficiency. In addition, the primary coil could have been damaged as a result of being handled roughly while reassembling the core. Based on this information, I determined that my design needed revision, so I got another microwave transformer. First, I decided that instead of cutting through the core itself, I would pop the welds holding the E and the I sections of the new transformer core together in order to reduce the damage to the core. I also decided not to use electrodes because looping the exposed wire from the cable around the resistors held them in place much better than the U-shaped copper. I popped through the welds with some light passes from the angle grinder, removed both coils and current control shunts, and only reinstalled the primary coil as both the secondary coil and the shunts were not necessary. Then I wound a 10-gauge wire with 4 turns as the secondary coil. The rewiring process for the new apparatus was also pretty simple, as all I needed to do was place the spade connections on a salvaged wall wire onto the terminals in the transformer. The new apparatus worked well. Got the cover on, so we're all good. Yeah, send it. Alright. Yeah, so again, melted almost instantly. Alright, send it. Send it. Alright, stop. Is that what you wanted? Yep, that worked. Okay, send it. Now this one I need to back up a bit. Alright, send it.
You know, I thought about pulling out as
Okay, how do I stop this? Here we go.
Maybe this is gonna limit usability.
Thanks for watching.